So you just listened to Professor Franz Meyer talk about all of the background of the SAR data. Some of you we got to talk to a couple months back about a little bit more in depth. It was a 5-day training period about all these different products and how they work. I hope it's somewhat obvious that when you're working in your daily schedule, that being able to reference, these longer videos that have been made for this, for these different products, especially as it's new, these quick guides are designed to be reminders of the training to, kind of highlight the things that were in the training, to remind you of where the pieces and parts come from, to serve as a quick reference. And also, as you're learning the products, especially in this particular case, the SAR RGB, it can be a little complicated to learn to interpret all the colors. And so hopefully the information found in these quick guides is set up to allow you to print it off, in color, and then reference the information in such a way where it's complementary to the work you're doing at your workstation, especially when you have other ancillary data sets available. And so, it's got a little bit of background and, an image to remind you what the product is supposed to look like. Specifically here in the SAR RGB quick guide, I wanted to spend a little bit of time because, a red, green, blue composite image, when we're talking about a false color image, how the composite is designed basically controls how the colors that you see in the image. And so although in the image above you can see that we have, water is blue and most of the vegetation is green, and then you've got some fun colors of orange and yellows. When you zoom in, those are going to become a lot more distinct. And understanding what contributions there are into your red channel, your green channel, and your blue channel, and where predominantly the signal is coming from. In those areas, for example, that are very green, you would expect that the green channel is the primary color channel, color gun basically for that part of the image. And that's because the volume scattering that you would see bouncing off of trees and vegetation, for example, is very dominant. Whereas in the areas of water, that green channel would be very low. You would get on a 0 to 255 scale, as how RGB color guns are designed, the green is going to be much more towards the 255 range in the areas of vegetation, whereas in water it's going to be much more closer to 0, thus allowing those blue colors of this particular RGB, which are designed to be the very low end of your copol. Again, looking at that specular refraction that goes on, so you're not getting a very high signal. That channel is designed to highlight where those areas are really dark, and that way you get the blue colors. And so hopefully as you play with the data, as you are able to compare it to local maps, other data sets that you have, other satellite remote sensing data sets, you'll start to generate a bit of a muscle memory of how this RGB is connected, and that's what this RGB quick guide is designed to do. Again, highlighting what Franz just got done and over with, reminders on what it's supposed to be used for, what its strengths are, some things to keep in mind, not necessarily weaknesses, but they can be if they're interpreted incorrectly. And again, this is where we're really looking for your feedback as you get used to using both the products, and then having the quick guides and the training available to you is understanding what works and what doesn't. Are there areas that we should have highlighted a little bit more? Are there areas you'd like to see highlighted differently? Everybody learns differently, so it's always very intriguing to me how best to put into, a 2-page document without trying to cram too much information into it. All of the bits and pieces that are good to remember. And so on the back side of this 2-page document, you'll see that we include an interpretation graph. I've zoomed into an area and, you know, tried to highlight what the different features look like and how you use the colors to basically tell you what you're looking at. And so in this particular case, we've determined that most of our water is going to show up either, you know, the blues and the blacks, and your green is going to be vegetation. But you've got areas where you've got these oranges and these rust colors and such. And basically what the interpretation guide is doing is giving you an example of, you know, what crops tend to look like, or what suburban areas tend to look like. And again, this is where being able to compare with other data sets will help allow you to kind of, again, you know, try to see what these areas look like, so you'll start to recognize them. The terrain obviously is going to be in some places very easy to pick out, as you know, was shown earlier in Franz's presentation. You do get a lot of the ridging that shows up, especially in the mountainous areas of the domain, but these are designed to helpfully serve as reminders of what was in the training, some things to keep in mind as you get used to it. And so in this particular case, the caveats that were talked about during the training the last time for the RGBs and examples of what those look like. So earlier, Franz mentioned wind on water. In this image here in the center in the caveats, this is an example of a fairly large water body that's not too far away from Houston, Texas. And there were some leftover hurricane winds on the surface of the water. And so going from that nice dark, you know, blue, dark black color that you would expect to see, the winds very much brightened the RGB as it did with the surrounding area. Remember, of course, that it's sensitive to not only the roughness of the surface, but the moisture of the surface. And so the RGB sometimes is a really good indicator of areas that are a lot more moist than areas that were not, you know, in the previous image. So you can see the difference in how dark this green is here and how bright this green is here. Again, it could also be part of the growing season where you have much more vegetation that's scattering the signal in different places. And so again, looking at the same areas in a time series will help you learn to interpret these images in a way that's useful to you. But specifically here, seeing the shades of orange, you typically don't see orange on water, and that's just a signal of how rough the surface is. And again, as a reminder, since Franz already showed it, again, as a caveat, seeing where the colors abruptly change. The RGBs showed the calibration errors, I think, a little bit better than the water extent product does. So I tend to use the products together. I find it's easier to understand when I'm looking at the water extents where I would expect water to be. Again, highlighting the areas where there's these really, really thin rivers, I can see that it's, you know, some sort of water feature in the RGB, but yet it's possible my water extent won't tell me that. But it's nice to know the difference between, say, a water feature and then, say, for example, a road feature, you know, that which also would be, you know, in some cases, at least in my backyard, we have these huge highway structures that take on the appearance of rivers, you know, in some areas around the state of Alabama. So that would be an area that I would, you know, definitely enjoy having another piece of information available to me. I'm going to switch now to the surface water extent. I heard somebody speak. Is there a question?
Oh, that was me.
Oh,
I was just saying, so when you see later, when you look at the actual service, you will see that you can animate these data sets over time.
Exactly.
And using this quick guide hopefully will help you somewhat understand, you know, if you see changes over time, what these changes mean, how to interpret these changes. And so we would like to know if you find those quick guides useful, if you felt like there was information that you would have liked to know that wasn't available. We would like this kind of information, or if there was something confusing on the quick guides, please give us that feedback later on.
So let's see, let's try this. So hopefully now the surface water extent quick guide is showing. Hopefully it switched over. Yay, yes. Wonderful. And so hopefully some of the images in this one are going to be quite familiar to you, since Franz just went over some of them. Again, trying to highlight that we are trying to use these 2-page documents as a reminder. of the, I believe Franz spoke for maybe 35 minutes today. And, the ability and the time that you have in your daily workflow to be able to go and reference quickly, an hour-long training, and find the one piece of information that you needed, or to go through a slide deck that might have 40 or 50 slides in it. Hopefully this is going to serve as, a little bit of just a quick check. And so the graph of how the water extent is made, hopefully the reminder of how we determine where water is. Again, impacts on use and things to keep in mind. And then hopefully, yep. And hopefully you're seeing the back page of the quick guide. Again, these images should look familiar to you because we just went over them with the training that Franz just gave, trying to show out areas where, as a reminder, why am I not seeing a water extent in this particular area? Trying to understand where you can compare to your optical data. This happens to be a shortwave infrared RGB composite from Sentinel-2. On the very same exact day as the Sentinel-1 pass, there was just a couple hours in between the passes, and so the water on the ground shouldn't have changed so much to make it different, as was shown in the Missouri River case, where there were 4 days, between the two images, where water conditions could certainly change in that amount of time. But again, giving you an idea of what a mixed pixel area looks like along a narrow river versus in a cropland. This cropland area here, if you look in the optical data in the lower comparison product, there is in fact water in that field. But again, it's water surrounded by vegetation. And so those mixed pixels aren't enough to flag the water extent. And so giving you examples, where you're able to follow the same locations minus the arrows, since the images are small. And again, are the images too small? The beauty of building these tools is that they're totally interchangeable. If there's information on here that you don't find useful, then please give us feedback. There will be no upsetness. It's only learning for both of us. And so I very much look forward to your thoughts and comments, any type of feedback, both good and bad, and of course, first and foremost, your suggestions. And with that, I think I will stop sharing my screen unless there are any questions. Yes.
Maybe oh,
yeah.
yes.
Okay. If I may, thank you, Laurie, for that nice presentation. You showed a number of images. Okay. Both, the HydroSAR in terms of this RGB that you said, one is RGB and the other one is the one with the HydroSAR. Now, you also mentioned that, one from the other is different in terms of capturing the inundation and the water. Now, does it mean that we need to look at all the three products? You said ground verification. You also looked at the water extent images, and then you also have the RGB. So in what situation is this needed, is what I'm saying, because in all situations, this probably is not needed. So in what situation would that be needed? Exactly.
So your RGB is going to serve more as your qualitative analysis, being that it's an image raster. And doesn't lend itself very well to doing, say, analysis that you would use in the GIS world, with vectorized type data. Currently, the water extents are served out as a raster file, but they could easily be converted to a vector format for analysis. And again, that's the type of feedback that we're looking at. But the water extent product is actually qualitative in that the technique that's being used, that Franz has described up until this point, is actually picking out where we want the water, where we said there is water, that we have confidence that there is water. And so it's less about interpreting the colors that you would have in the raster, which is very qualitative and of course is going to differ from person to person and how they analyze the information, whereas the water extent is definitely a quantitative. The comparison to the optical data is more I would say, most people are more familiar with optical data. And so in many cases, when learning a new product, it's always helpful. It can be very helpful to show comparisons of something that most people is already familiar with. And so the optical data is there. You'll find that in many cases, we had to search very hard for those comparison days of where the optical data was available. You know, SAR definitely has the benefits of being able to see through the clouds. And from what I've observed, just from the last couple of months of watching over your region, you guys don't have a lot of cloud-free days. So the ability to use remote sensing when you can't see through the clouds is a hindrance. And so we certainly did look very hard to show those as examples, but if there are other data sets that you use to tell you when water is available, especially I would imagine you have ground networks that we maybe not have access to. But again, from the satellite perspective, we're trying to flag all of the water that we can see. Does that answer your question?
Yes, thank you. Thank you, Dora.
Wonderful.
Yeah, I think using both, once you have a little bit of familiarity with the RGB product, it's often useful to, you know, look off and on. If you look at the water product and you want to know more about what's going on and what causes this the flooding in this location, it often helps me at least to look back at the RGB and, you know, get a bit of a clear idea of what I'm looking at and where that detection comes from.